Let's talk about dividing polynomials. For a quick warm-up, let's see if you remember how to do old school long division. The question is, divide 337 by 4. We used to set it up like this. We'd put what we were dividing it by on the outside of that little curve thing, and then we'd put the question 337 underneath. You would then go and check. You would say, well, how many times does 4 go into 3? The answer is none. So then we go, how many times does 4 go into 33? The answer is 8. And so then I would multiply. I would say, okay, well, what's 4 times 8? That's 32. And then I would subtract. 33, take away 32 is 1. And now I need to bring down my 7, and the process repeats. How many times does 4 go into 17? The answer is 4. 4 times 4 is 16. And now I subtract, leaving me with 1. 4 cannot go into 1, and therefore 1 is going to be our remainder. You may have remembered that term from elementary school. So there's a really funny way of writing this that's going to be sort of useful for how we're going to be writing our division today. What we could say is that 337 is equal to 4 times 84 plus 1. 4 being the number that we were dividing it by, 87 being the number that was divided into, and then of course 1 is the remainder. And when we're dividing polynomials, we are going to write our answers in a very similar format. We just are using these different sort of letters and terminology, okay? Our d of x is the divisor, so that matches up with the 4 that we had before. And so you could say to yourself, the divisor is, what am I dividing by? So in our previous question, we were dividing by 4. Q of x matches up with 84, and that is our quotient. The quotient is the result of the division. And lastly, we had our remainder, r of x. The remainder is how much is left over if it didn't divide evenly. And in our previous example, it was 1. 1 was the remainder. That's the gist for dividing polynomials. Let's do a couple of examples using a very similar process. Our question here is, divide x squared minus 7x minus 10 by 8 plus 2x. Well, we have our divisor. We are being divided by x plus 2. And so I'm going to write x plus 2 on the outside of that curvy thing. On the inside is where you put your original question, x squared minus 7x minus 10. And here's how long division goes. I'm going to be comparing the first two terms in both of my question and in my divisor. So I'm going to say to myself, how many times does x go into x squared? Or you could think of it, what is x squared divided by x? That answer is x. So I'm going to put an x at the top here. And now we proceed just like we would with straight up long division. We multiply this by our divisor. X times x is x squared. X times positive 2 is plus 2x. And just like we did before, well, now we are going to subtract. I'm putting a little bracket around the x squared plus 2x as a reminder that I'm subtracting x squared and I should be subtracting 2x, not adding. X squared take away x squared is just 0. Negative 7x take away 2x is negative 9x. Okay, now I'm going to bring down my negative 10 and we're going to repeat. Now I'm going to ask myself, okay, how many times does x go into negative 9x? These two start to match up. We'll pick a different color. Alternatively, you could say, well, what is negative 9x divided by x? And the answer is negative 9. So I write negative 9 up top here. And we repeat. We go negative 9 times x plus 2. Negative 9 times x is negative 9x. And negative 9 times positive 2 is negative 18. Time to subtract. Once again, I'm using brackets as a reminder that I am subtracting this entire thing. Negative 9x take away negative 9x is just nothing. Negative 10 take away negative 18 is going to be positive 8. Now we're stuck. There's nothing further that we can do. As I've highlighted here, when the degree of the remainder is less than the degree of the divisor, you're done. So in this case, the degree of our remainder is 0. There are no variables attached to it. Whereas the degree of the divisor, x plus 2, is 1. We cannot continue. There's no x's to be divided by, so this is the answer. If we wanted to write this out, I'm going to start by writing my initial question. X squared, take away 7x, take away 10. And we're going to go back to that format that we saw previously. We start by writing the divisor, and in this case the divisor was x plus 2. And then we go and we write our quotient, which is the result of the division. The result of the division in this case was the stuff at the top, or x plus 9. And then I need to add my remainder, which was 8. And here we have a completed long division. Let's go on to another example here. In this example that I've provided you, it's a little bit trickier because we are missing terms. And what do I mean by that? If you were to actually write this out, okay, there would be, in descending order of terms, what we're missing is a term in this question that has an x on it, just an x to the power of 1. We have an x cubed, we have an x squared, but we don't have is an x. And when you're doing long division, it's important to remember you need to sort of add that bonus term in, okay? Let me show you what it looks like here. We'll set up the problem the exact same way. I have an x minus 2 on the outside, and I put my question underneath. X cubed take away x squared minus 4. But I need to add that extra term in. So what I'm going to do is I'm going to shift the negative 4 over, and I'm just going to add, and I'll do it in hot pink, a 0x. 0 times x is just 0, so I'm not actually adding anything here. It's just for notation purposes that allows me to do the long division. And now I'm going to continue with the usual process. Once again, I compare my first term, x cubed, of the question, with the first term of the divisor, which is x. And I say, well, what's x cubed divided by x? That's x squared. X squared times x is x cubed. And then I would go x squared times negative 2 is negative 2x squared. And then I need to subtract all of that, leaving me with a positive x squared. Now I bring down my 0x, and just stay with me here. Repeat the process. X squared divided by x is just x. So I'm going to add an x up top. I multiply. X times x is x squared. X times negative 2 is negative 2x. And I subtract the whole thing. 0x take away negative 2x is positive 2x. And if we hadn't had that 0 here, this 2x would have been lost and the division would have been incomplete. That's why we need to include that 0x as a placeholder until we're completed the question. Now I can drop down my negative 4. Once again, I repeat. 2x divided by x is 2. So I'm going to add a 2 up top here. 2 times x is 2x. 2 times negative 2 is negative 4. And look at this. We are going to have a remainder of 0. Oh my gosh, it's like I knew that was going to happen because I pre-wrote this little note off to the side there. If the remainder is 0, which is the situation that we have here, then what we've actually determined is that our divisor, right, the divisor being x minus 2, is a factor of our polynomial expression. And think back to our first unit when we were graphing our polynomials. It was important for us to know what our factors were so that we could determine where our x-intercepts were. And that is a good chunk of this unit, is simply determining where are the factors of these long polynomial expressions so that we are able to graph and actually make use of these stupidly long equations. Okay? So let's actually write this out properly. Let's finish the question properly. We're going to write our initial question, x cubed, take away x squared minus 4 equals. I start with my divisor, x minus 2. And then I get my quotient, which was x squared plus x plus 2. There is no remainder, so I don't have to write anything onto the end. Beautiful. Let's do one more problem. This is a nice long one. I set it up the exact same way. I put my divisor on the outside, and I write my question in the middle. As I'm writing it, I'm checking to make sure that I have a term with degrees in descending order, and I can see that. I've got a 4, a 3, a 2, a 1, and then a 0, so I don't have to add any bonus terms here. And this is a long question, but truly nothing is going to change in our process. Let's start. Check against the first terms. 3x to the 4 divided by x squared will leave me with 3x squared. I multiply. 3x squared times x squared is 3x to the 4. 3x squared times negative 3x is going to be negative 9x cubed. 3x squared times positive 1 is 3x squared. I subtract the whole thing. 3x to the 4, take away 3x to the 4 is nothing. 2x cubed, take away negative 9x cubed is like saying negative 2x cubed plus 9x cubed, which will be 7x cubed. And then 4x squared, take away 3x squared is just an x squared. I bring down my negative 7x. And the process repeats. Now I take my first term, 7x cubed, divided by x squared, leaving me with 7x. I multiply 7x times x squared is 7x cubed. 7x times negative 3x is negative 21x squared. And then 7x plus 1 is positive 7x. I subtract. 7x cubed, take away 7x cubed is nothing. X squared, take away negative 21x squared is positive 22x squared. And then negative 7x, take away 7x is negative 14x. Drop down the positive 4. And repeat. 22x squared divided by x squared is 22. So I add a 22 up top. Now we multiply 22x squared, 22 times x squared is 22x squared. 22 times negative 3x is negative 66x. And 22 times 1 is 22. Subtract. First term is cancel out. Negative 14x, take away negative 66x is positive 52x. 4 take away 22 is negative 18. And at this point in time, I stop. This term has a lower degree than my divisor. This x has a degree of 1, whereas this guy has a degree of 2. We are done. We are at our conclusion. And so we can now write out our final statement. I write my initial question. 3x to the 4, take away 2x cubed, plus 4x squared, minus 7x plus 4 is equal to, I start with my divisor, x squared minus 3x plus 1. Then I write my quotient, 3x squared plus 7x plus 22. Plus my remainder. And that's the end.